Welcome to this video on discrete random variables. By the end of this video, you should be able to use probability distribution of a discrete random variable to calculate the probability of an event. You should be able to make a histogram to display the probability distribution of a discrete random variable and describe its shape. And you should be able to calculate and interpret the mean, also called the expected value, of a discrete random variable. Alright, so during class today, I took a survey to find out how many siblings our classmates had. So we're going to make a probability model, and to be valid, which is going to help you answer the first one, all of our probabilities must be between 0 and 1. So I don't want to just write the number of people who had one sibling. I want to write them out of the total number of people. So there were 3 people who had one sibling out of the 30 people in class. There were 7 people who had 2 siblings out of the 30 people in class. 9 people had 3 siblings. 5 people had 4 siblings. 3 people had 5 siblings. 2 people had 6 siblings. Nobody had 7 siblings. And 1 person had 8. All right, so what I would like you to do is go ahead and pause the video and answer 1 and 2, and then come back and see how you did. All right, so the first question, is this a valid probability model? When you add up all of the number of people with their siblings, you get 30 out of 30, which is 1. So the probabilities add to 1. And all of our probabilities are between 0 and 1. You can convert these to decimals and see that they are all between 0 and 1. Is 5.7167 a possible value for x? So they say right here, let x equal the number of children. Okay, so they're saying the variable x is the number of children. Can you have 5.7167 children? You cannot. No partial children, so that is not a possible value for our variable. Now we're going to make a histogram. So what I recommend is go and convert all of these to their decimal forms. And to draw our histogram, we're going to put all our values of x down here. We have 1 through 8, so we've got 1, 2, 3, 4, 6, 7, 8, and that is the number of children. Okay. And over here on our side, this is our probability. So we want to, let's say, like 0.05, 0.10, 0.15, 0.20, and so finish your scale going up the side, and then you can look at these probabilities and make your bar that tall. So this is a histogram, so the bars are going to touch. Remember, you want to try and make them at the same width as much as possible, and come back when you're done making your histogram. Alright, so hopefully your histogram looks something like this. Now we're going to describe it. So if we look at the shape, you always kind of imagine, what if we draped a towel over this shape? We're going to end up with a skewed right because the tail is on the right. And there's a single peak at 3. All right, so let's talk about a couple of these probabilities here. So let's describe in words what the probability of x greater than or equal to 3 is, and then find the probability. So the probability is, what we're talking about here is we're talking about the probability of randomly selecting a student that has 3 or more children in their family. All right, so the probability of randomly selecting a student with 3 or more children in the family, because we have an equal to sign here. So when you count up the probability of 3, 4, 5, 6, 7, and 8, you get 20 out of the 30 people had 3 or more children in their family. Then the Part 5 says describe in words what the probability of x is greater than 3 and then find the probability. So this is the probability of randomly selecting a student with more than 3 children. So we're not including 3 in this one because it doesn't have the equal to's. When you count those up, you get 11 out of 30. All right, so let's take a look at number 6 together. It says find the average of the x values. So if we come back up here, here are x values, 1, 2, 3, 4, 5, 6, 7, 8. And it says find the value of them. Okay, the average of them. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. And there's 8 categories, so I'm going to divide them. And that gives us an average. So we get 36 over 8 with an average of 4.5. So hopefully you are kind of going, why are you doing that? And you're kind of wondering, that doesn't even make sense to average those numbers because we're actually talking about the numbers down here, not the numbers up here in our x in our variable. Okay, so this does not tell us, it's not a good representation. So let's see why. If we take a look, there's a lot of people. Like our peak was at 3 children. It's carrying a little bit more weight than the rest of them. So how you account for that is we're going to do something called a weighted average. And this is really how your grades are calculated in Canvas when we have the different percentages on the grade categories. So you would take whatever your average is and then you'd multiply it by the weight. Well, the weight is just like a probability. It's a percentage, and then so you write it as a decimal. And so what we call this is we call it expected value. So this is a way to get the mean when we have these different probabilities of an event happening. And the official definition of this is you're going to find, remember mu is mean, the mean of the random variable x equals the sum of each variable number times its probability. So let's kind of look at what this is going to look like. So we have a random variable x of 1, and the probability of one child was 3 out of 30, plus you had a random variable 2, and the probability of 2 children was 7 out of 30, plus 3 times 9 out of 30. So what I'd like you to do is finish this out, write all the rest of them, calculate it, and let's look at the actual mean of this distribution. All right, so I set this up and I got an average of 3.3. So on average, there are 3 students. And if we look at our histogram, that's what we're really kind of feeling here too. And so when you have outcomes that all have different probabilities of them happening, you have to weight them and multiply by the variable that we're talking about. So this is expected value. It's how we find the mean of these kinds of probability distributions because they don't all have the same probability of occurring. All right, so let's flip this over and summarize. All right, so one thing I want to remind you of, our probability distribution, that's our probability distribution we showed on the front. Remember, we're going to have some sort of x variable. It will be defined for you what x is, or you may have to define it when you're writing these down if you're just given the problem, and all the possible outcomes that are possible. So we had the x was the number of children, and then we had 1 through 8 for the number of children. And then we have the probability of that event occurring, and you'll have all the probabilities here. Same rules. This should total, your probability should total 1 and all be between 0 and 1. Then we had a discrete random variable. So what a discrete random variable is, it takes a fixed number of values with gaps between the values. A fixed number of values with gaps between the values. What do I mean by that? Well, let's flip this back over and take a look. It refers to right here, where is 5.7167 a possible value for x? No, because you can't have part of a sibling. Because our variable is discrete, there are no numbers in between. There is one child or two children. There are not numbers in between those. So there's a space, there's a gap between the numbers. We'll continue with lessons where we talk about continuous random variables, but you have to recognize if they're discrete or they're continuous. Are there numbers that exist between them, or you have to skip numbers because there's nothing in between? All right, so that's a discrete random variable. And then we talked about our histogram. So when you draw your histogram, you want to put the probabilities here, not the raw count, not a number, it's the probability. And down here, you're going to put your values of x. You want to make your bins about the same width and make it the appropriate height based on their probability. And to find the mean of these distributions, to find the average, we call it expected value. The average of the random variable x will be found by adding together each variable outcome possible times its probability, and then add them all together. So what I'd like you to do is pause the video, try to check your understanding on your own. Don't just copy it, because you know I'm going to give you all the answers, but I want you to try and see, what are you understanding and what do you want to take a more look at. Pause the video, do the check your understanding, and come back when you're done. All right, so we had our Home Alone movies. Believe it or not, there are 5 of them. So it's a series of American Christmas family comedy films created by John Hughes. There are 5 Home Alone movies, and below is the probability distribution of the number of Home Alone movies watched by a very large sample of high school students. All right, so here we have our amounts. We had 1 missing, so to find that, we took 1 minus each of these and came up with 0.08, so that's what's going to go there. Explain in words what the probability of x is greater than 3 means, so we want to be in context here, because context is important. So this is the probability of a randomly selected high school student that watched 3 or more Home Alone movies. And when you find it, you're going to add together the probability of 3, the probability of 4, and the probability of 5, and I got 0.11. All right, then we have our histogram. And so up the side, I had my probabilities. I had my x values across the bottom. I put my title in here, and I drew my bins to be as tall as to go to our probability. And we ended up with a skewed right with a peak at 1 movie. All right, and our last one, calculate and interpret the expected value of x. Okay, so you take the outcome times its probability plus the outcome times its probability all the way across, and I got 1.43. So that means if many students are randomly selected, the average number of Home Alone movies seen is about 1.43. All right, hopefully that was helpful. Let me know if you have any questions. See you in class.